Alright, I am going to go over the oscillator class. I'm just starting with an empty scene. I took my main camera and I'm setting it to 0, 0, and I'm setting my background color to black. This is always a good place to start for everything. Now I'm going to make a empty game object, and I'm just going to name this LFO. And I'm going to add an oscillator LFO component to the object. So while I go over the variables, I'm going to go into play mode. And what you'll see in the wave display is a sine wave. It's going to go from 1 down to -1 and up to 1 over the course of 1 second. So this display range is time-based. So I'm seeing 1 second here, I'm seeing 10 seconds here. By default, it's set to 1. I can see that it's going from -1 to 1 because my trough and my crest are set to -1 and 1. If I want to get some visual feedback with what's going on, I can go down here to this line display. You do not need to turn on the line display. This is just for visualizing the wave, but there are other ways to visualize it. But for now, I'm just going to turn this on, and I'm going to move this oscillator back in space. So it is showing this line is going from -1 units to 1 unit, and it's going from 0 units to 1 unit over the course of a second. So I can also change the length of my line display, so it's just showing 100 line segments. So I'm just going to make that a bit longer so I can see a little bit more. I can adjust my low and my high bounds here, make those whenever I want. I'm going to leave those at defaults. My clamp low and clamp high basically lets me clip my curve like this, so I can have a high bound and a low bound like this. So now I have something a bit more like a square wave just because I'm chopping off the top and bottom. For now, I'm going to leave these at nice low and high numbers because I don't want to clamp anything. The offset is like an add, so this is taking my -1 and 1 and adding to it. So if I add 1, it's now going from 0 to 2. And then time offset is phase. So if I offset this by 0.5, that is actually offsetting it by pi. So what I'm doing under the hood is, if I was just sampling by time, or if I was just sampling by a regular number, in order to create a full oscillation, this would require that I go from 0 to 2 pi, or around 6.28. But I'm doing some multiplication under the hood so that I can keep my numbers whole. So it is doing a full 0 to 2 pi over the course of 1 second because my speed is set to 1. But before I get there, I will talk about multiply. So multiply is also something that happens after my trough and my crest. So this is an overall multiply. And then my add is happening in addition to that. So I'm just going to leave my multiply at 1. So my speed is actually set up so that if this is set to, let's say, 5, now I have 1 oscillation happening over the course of 5 seconds instead of 1. If I set this to 0.5, then I now have 2 oscillations happening over the course of 1 second. So counter power and sine power both affect the shape of the curve. So this sort of bends this curve one way or the other. And sine power basically takes the output sine wave and applies a power curve to it. Now anything below 0 is going to not be affected. So if I do want to see the effect of this, I need to have my trough be at 0 so that I can reshape my sine curve. So I can make it bounce, or I can give it kind of a spike effect. Usually I don't mess with these too much. So I'm just going to go back to the defaults for that. Quantize is about stepping. So instead of smoothly going up and down, I am now going to be going at regular intervals. Generally, this number is set to 1,000 by default. So then in here I have alternative curves. So in addition to sine waves, we can also use a noise curve. So this is aperiodic, and it will give us roughly the same values of -1 to 1, but it doesn't always go up to 1 and -1. We get lots of other values. In the middle there, if I change the speed, you can see more of what happens to noise over time. This is Perlin noise, but it is a custom implementation of Perlin noise. There is a built-in Perlin noise in Unity, and I am not using that one. I am using a different library for this noise that's a little better. So we can also use a custom curve. So if I click custom, by default, I just get a straight line, but if I click here, I can choose from any number of different curves. So I can make a sawtooth curve. And these are ones that I just made and added into Unity. You can create your own curves and add them. So this is a sine wave. This is an inverse sine wave. This is sort of a square wave with a bit of a bump, so not a perfect square wave. This is a curve that just fades in and out. So I use this to just like as a default starting place to fade things in and out over a period of time. So this is useful if I wanted to say have something appear and do something and then disappear, and let's say I wanted that to take a minute. If I set this to 60, then what that means is that over the course of 1 minute, it will fade in and then hold and then fade out at the end of that minute. So I'm just going to set that back to those defaults. So don't loop custom curve. It's not showing up here, but what that means is it will play through the custom curve once, and at the end it will just hold at whatever the end value is. So I'll leave those off for now. Lazy will make more sense when I start animating something, so this is a useful thing to combine with quantize. Mostly you don't have to worry about lazy. Now, oscillators and triggers are places where we can insert other oscillators. We can combine oscillators together and change all of these values. Triggers are similar to oscillators, but they are just meant to be single values. So oscillators are meant to be things that change, and triggers are meant to just be things that get set. So if we wanted to say set up a button presses to affect things, we can do that with triggers. So I am going to go ahead and create a sphere. I'm just going to reset the transforms at first, and I'm going to move it out a few units. So this is now 3 meters away in VR space. I'm going to create a new object, and I'm going to call this xform. And I have some additional things as part of the system. I have plugs. So plugs basically allow me to connect triggers and oscillators into the properties of different objects. And I have lots of different kinds of plugs. And all of these plug scripts mostly are pretty simple, and they should be fairly easy for you to extend and make your own for when you want to connect oscillators to your own scripts. So I have one here called plug xform multi. So what I'm going to do is plug my sphere into the target. This is the object that will move. I'm going to take my oscillator and plug it into oscillator, and then I'm going to click on TY. So now this sphere is bouncing up and down once per second. And I can do this with any of these values. So I can do it for scale and rotation, and I can transform in different axes, of course, as well. So you can see wherever it was when I stop, that's where the sphere will wind up. So I'm just going to reset this really quick, and then I'm going to plug that back into TX. Now what I want to do is just show you how to make a circle really quick. I'm going to duplicate this oscillator, and I am going to duplicate this X form, and I am going to take this second oscillator and plug it into here, and I am going to have it affect the ty instead of the tx. Now, you'll notice that by default it just started making a circle, but that was actually just by chance. If I go back up here and I say reset all counters, this is what should actually come in. So the reason that I have this reset all counters button is that this oscillator is not based on time, it's based on an internal counter. So because I duplicated this oscillator, that initial counter was just offset. So in order to, as I'm working with this, the oscillators are going to be offset from each other as I'm working with them live. But if I want to reset all of the counters so that all of my counters are realigned with each other and they all match, I can just click this reset all counters button. So now they're all aligned as they would be if you just hit play at the start of the scene. So what I can do now is adjust the time offset to 0.25. So sine wave and a cosine wave are just offset by half pi, basically. They do the same thing. And this is how you draw a circle. You have sine in one direction and you have cosine in the other direction. And now I have a circle. Now for organization's sake, I am going to create an empty game object, and I'm just going to say draw a circle, and I'm going to move this stuff into my draw a circle game object. And just for reducing visual clutter, I don't think that I need these line displays, so I'm going to turn off my line displays. And now I just have a ball rotating. I did this all in play mode, and I want to save this. So what I'm going to do is I'm going to hit Control C, and I'm going to hit play. I just lost all my work, and I'm just going to paste it back in, and I got my work back. So now if I hit play, I should, if I did everything right, it should just go back to drawing a circle. Okay, very good. So I have a circle. I'm just going to double check that I am actually recording all this. Oh no. Okay, good. I'm streaming. I thought I wasn't streaming for a second. Okay, great. Okay, so now I have a circle. So now I'm just going to show you how to use an oscillator to multiply on top of another oscillator. So I'm going to create another game object, and I am going to make another LFO. And this time what I want to do is make the circle get bigger and smaller. So I'm just going to have it go from 0 to 1. And then I'm going to go into this oscillator, and I am going to say, make this a multiply oscillator. And I'm going to make this go a little slower. So I want it to take, say, 5 seconds to scale up and down. And I am going to plug this into multiply oscillate. And I'm going to plug it into this multiply oscillate as well. So now it starts to draw a big circle, and the circle goes back down. So it's basically going to be drawing spirals that scale up and down. Now, just for fun, maybe what I'll do is I'll create one more oscillator. And I'm going to make this go, I want to use this to adjust the scale of my circle. And I don't want it to have a huge effect. So I'm just going to go from 0.8 to 1. And then I'm going to make another game object. And I'm going to name this xform scale. And I'm going to parent it because this one is going to be affecting this one. Plug xform multi, so I'm going to do this, and I'm going to drop my sphere into the target, and I'm going to drop this oscillator in here, and then I'm going to set the scale. So it might be a little hard to read while it's moving a lot, but when it slows down, we can see the sphere scaling up and down. And I want to increase the speed a bit, so now it's scaling up and down So yeah, let me just scale this up more so you can see more dramatically what's going on. So now it's scaling up quite a lot. Alright, so now I'm going to, let's see, draw a jiggly spiral. Okay, so now I'm going to just copy all of this stuff into my draw a jiggly spiral. Copy that, when I hit play, I lose all of that, I paste it again, and now I have both of these in there. Now we can see both of them running at the same time. Okay, so what I want to do now is I'm just going to start again from scratch, and I'm going to make a new sphere, and I want to change the color of the sphere instead. So I'm going to go ahead and make another LFO for color. Make a plug for the color. Yeah, and you can basically name these whatever you want. So I'm just naming these for my own sanity, so I know what they are, and I'm going to parent these. But yes, the game object name does not have to connect to whatever the component is. That is up to us to define. So I am going to take my sphere and plug it into my target. I'm going to take my oscillator and plug it into the oscillator. And then I'm going to define a gradient. So I'm just going to make it go from red to green, let's say. And let's see, I think that's all I need to do. And I think by default it will guess the color channel name. So let's just see really quick if that's true or if I need to add a little extra something. Okay, so what I need to do is add color here. Okay, it looks like actually I need to drop this into the mesh renderer. Okay, so dropping it into the target was not quite enough. It didn't get the mesh renderer from that. The sphere has a mesh renderer component on it, and that's what we're actually affecting. So to get that to work with the sphere, I needed to drop it into the mesh renderer, and I needed to give it the color channel name. So when you make your own shaders, you might wind up having lots of different colors happening. So you can have as many plug colors as you want, and they can affect as many different color channels as you want. By default, any material in Unity generally has a color channel. If color is available, it's going to be called _C color. So by default, you can generally see that. Now, one thing you'll notice is that the circle is going from red to green, but it's staying on red for a while. And the reason for that is that my LFO is going from -1 to 1, but my gradient sampler clamps. So anything above 1 it ignores, and anything below 0 it ignores. So for this to work properly, I need to set my trough to 0. So now it's going to go smoothly from red to green. And of course, because this is a gradient, we can have as many values in between here as we want. So now we're going from red to blue to green and back over the course of 1 second. So this is how we can change color. So I'm going to create an empty game object again. I'm going to call it plug color, and I'm going to drop these objects in here. And just for demonstration purposes, I am also going to show you how to do that with a sprite, because we are mostly using sprites still. So I'm going to drop a circle sprite in here. And a sprite is an image, a PNG usually with transparency. And I am going to go ahead and just duplicate this whole thing. And instead of having a mesh renderer, which I'm going to get rid of, I'm going to plug in my circle into my sprite renderer. And now they're not doing the same thing because of my offsets with my counters. So if I reset these, now they're perfectly aligned and they're doing the exact same thing. But of course, these are being controlled by different oscillators. So I can, let's say, adjust the speed of one of them. So now they are doing the exact same thing every 2 seconds, because that is when both of these line up. Yeah, so as a reminder, whenever you say reset all counters, all of the underlying counters for all of the active oscillators in your scene will get reset back to 0. But as I play with them, as I add new ones, as I adjust things, my counters can get offset from each other. So this is a way to just see what should be happening with them when I hit play. Okay, so I'm going to copy that, paste that, delete these things, I don't need them anymore, and now I am going to show you how to adjust the speed of an oscillator. So I think that for simplicity, I'm just going to go back and duplicate this draw circle, and I just want to keep it simple, I'm just going to use one oscillator. I'm just going to translate in Y. I'm going to reset my sphere. And my LFO is basically default. And what I'm going to do now is I'm going to duplicate this oscillator. I'm going to make it a bit slower. And what I'm going to do is I'm going to use this oscillator to affect the speed of this one. So what I want to have happen is I want this to go from slow to fast. So in this case, I'm going to make this 0.5, so it's going to go from 2 Hertz up to 0.2 Hertz. So it's going to go from a speed of 1/2 to a speed of 5. So it's going to go from pretty slow to pretty fast, and I'll make that happen over 10 seconds. So I am going to go into my oscillator section and plug this LFO into my speed oscillator. So it's starting off nice and slow, gets faster and faster, and then it slows down again. So this kind of speeding up and slowing down action creates a sense of anticipation and relief very easily. So it can be very powerful connecting oscillators to each other. And of course, we can connect other oscillators to this oscillator. I can adjust the multiplication of that over time. I think I'll stop there with this one. Let's see. So yeah, for now I think I'll just keep this one its own simple thing. So I'm copying that, deleting this, pasting it back in. Now I have a bunch of these things going. And now, let's see, I'm just going to open up the plug folder and just show you quickly all the things that are here. So Xform is similar to Xform Multi, but you can only choose one item at a time. I can just show that to you very quickly. If I just plug in Xform, this is just if I know I only want to choose one channel, I can just pick from a drop-down. Shader variable is similar to color, but in this case we can basically affect any channel. So it can be a type of float, vector, or color, and with color, instead of using a gradient here, I set it to a min and a max color, so this lets you interpolate between 2 colors. And we can use any arbitrary channel. So this will be more important when you start making custom shaders. And the same thing works with these floats and these vectors. Basically, the idea is that the oscillator goes in and interpolates between any two of these variables. So again, this will be more valuable when we get into shader stuff. Listener volume is sort of a global value, so you can turn the volume of every audio source in your scene up and down just by changing the volume of the listener. And that, like, there's no variables in here, you just plug in the oscillator and that's what you get. That'll be a value between 0 and 1. Helm is a specific plugin that is no longer supported, so I'll probably just, maybe I'll just delete that because it's been deprecated. Goodbye, Helm. And then we have a lot of audio tools. So the chorus, high pass, reverb, reverb zone, these are all audio effects, the low pass one as well. And then audio source is probably the most important one that we'll use for audio. And maybe I'll just jump in and show you how to do some stuff with audio really quick. So I'm going to make a audio source. So I'm going to make an audio source, and I'm going to attach a audio clip, and I'm just going to do a lower frequency sine wave. So I'm just choosing 174. I'm going to set it to loop. And then what I'm going to do is create another LFO. And I am going to make a few of these. So I'm going to make a volume, and I'm going to make a pan, and I'm going to make a pitch. So for the volume, I'm just going to go ahead and go from 0 to 1. For the pan, I'm going to leave it -1 to 1. -1 would be the left ear, 1 would be the right ear, and pitch. I'm going to have this go from 0.5 to 1. And then I'm going to make a plug audio source. And there's a lot of stuff here, but primarily we're going to be interested in the things up here first. So I'm going to plug in my audio source, and I'm going to plug in my volume oscillator, and my pan oscillator, and my pitch oscillator. Did I get that right? Volume, pitch, and pan. Cool. So when I hit play, this might be somewhat cacophonous, but let's see. Alright. So my pan is going left and right at the same speed as my volume. They're all going the same speed because they all have a speed of 1. And this is the easiest way you can go in and use oscillators to affect attributes of the audio source. So I just make a group for this and save this one out. Alright, I'm going to hide that one, so I might just do one more for now. I'm going to make another audio source. And I'm going to choose a one-shot audio clip. I have this bell sound effect. And then I am going to create an empty, I'm going to create an LFO. I'm going to create another plug. So I'm going to plug my audio source into audio source. And I'm going to plug my LFO into play oscillator. And I'm just going to hit play. So what's happening here is basically every time the LFO goes from below 0 to above 0, it triggers this audio source to play. Now I can do something even a little bit fancier. If I choose instantiate source, then it's going to actually make duplicates. So this is nice because this bell doesn't just stop, right? So by instantiating this audio source, we allow that audio to continue playing until it's finished playing, and then it gets destroyed. So if you have like a gong and you want to play another gong on top of it, it will just keep going. So that's most of what you need to know about instantiating audio sources. But let's see, we can also get a little fancier if we want, and I have something called clip parent. And what that allows us to do is to have a number of different sound effects that will get played. So I'm just going to make an empty clip parent, and I'll drop this audio source in here. Oop, no, let's see, I want to actually, I'm going to duplicate that, put that in the clip parent, duplicate that, have a different audio clip. So we don't have any other bells right now, so I will just use a little blue noise. And then if I go back to my audio source and I plug in this clip parent, then it should alternate between playing the bell and playing a basically what's happening is it's going to play the bell and then it's going to play the noise, and it's going to play the bell and it's going to play the noise. And you can actually just you can deactivate this clip parent because we don't want to hear these sounds when we hit play. So this is getting a little more complicated, so I'm actually just not going to save this. But this gets interesting if you want to start making more complex rhythms. You could have like a drum and then a shaker to say go along with it. We can also randomize clips if you want to have lots of different kinds of instruments playing at different times. If we want to, we can also crop our audio clips. If we have an audio clip that has like different qualities going throughout. If we have voiceover, for instance, we can set it up so that it will play voiceover starting at different points. And this gets a bit deep, but hopefully that's enough to get you started. So I'm just going to create an empty game object here, and I'm going to call it audio instantiates. All right, so this is, so we can also, let's see, so we can activate game objects here. So we can turn on and off sets of game objects with activate. I can play animations here, so when the trigger gets set, it will actually like scrub through an animation, and you need to set up your animator in a certain way for that to work properly. Under trigger, a basic trigger, I haven't shown you that at all, but I'll get to that in the future. So a trigger just has a value. So if you plug in an oscillator and a trigger, it will just multiply those values together. But I have some interesting triggers, such as a trigger to detect breath from a headset. So if you have a VR headset on, it can actually detect your rate of breathing. It does a not bad job of detecting your heartbeat and your BPM directly from a headset. I also have an audio volume trigger, so if you plug in your own MP3 file, it will give you a value out that is the amplitude of that MP3 file. So this is an easy way to make audio reactive effects. Lazy is basically a way to smooth out any inputs that are happening. Math allows you to just combine triggers and oscillators together with different math functions. We can get the audio volume of the microphone as well, which is interesting for like voice feedback. Remap allows us to take values and remap them. So like a 0 to 1, it can become a 0 to 10, for instance. And then I have an entire node-based system as well, which I will be showing you in the future, which uses Unity's visual scripting graph, which is actually a much nicer way to play with all of this stuff. So hopefully this is enough to get you started. And I'm going to stop this here, and I'm going to be, I've made a couple updates to the synth package, and what you're going to need to do is, I'm going to show this in the Explorer. If I go to my Explorer window and type command space dot, and I want to go into my synth package, to pull the latest stuff, I want to make sure that I'm on the NYU branch. So I want to make sure that I am in my, I thought I was in my NYU branch. I guess I'm not. Git branch NYU, and then, git check out NYU, and then I want to git pull origin NYU. So ignore these errors. You should be on the NYU branch, and you should git pull origin NYU to make sure that you get all of the latest updates that I have for the synth package. And I will also be pushing this into the TSI project so you can get all of these demos as well. So